Today in class we had an activity where we supposed there were 4 pharmaceutical companies all vying for the market of pain relief to people with severe back pain. They're comparing their product against the mean of 50 that's the current status quo by the current medicine. Each one of these pharmaceuticals has their own unknown mean. Mu sub A is less than 50, mu sub B less than 50. They're all claiming to be better and less than 50. So we had company C over here. Their first result was a mean of 48.5. It led to a p-value of 0.115, not enough evidence to convict, so we could not claim that their medicine is working. We failed to reject the null. Here's company B over here. They actually got a statistically significant result. They got 47.6. The p-value is 0.027. They rejected the null. The evidence would suggest that this is working. There was company D back here. Well, company A was bad. They were above 50 for their mean average, so they're just about out of the running. These guys had a fairly low mean, but it wasn't low enough. They had a p-value of, what was that, 0.13, so failed to reject. I think I failed to mention that we had samples of size 16, so our standard deviation for the sample means 1.25. Well, then what happened was I shared with them 4 more hypothetical trials that were run. So company C, you can see they never made it into the critical region, so they're out of the running. Their medicine is not working. Company B was interesting. Their first result was down here at a p-value of 0.027, but all 4 of the ensuing trials yielded mean averages up around 50 and only one below. This implies that there was a type 1 error made. The first test that they ran, that low sample mean must have been due to random chance, but it was a 0.027, so we rejected it all and thought the evidence, well, it did. The evidence suggested the alternative was true and the medicine's working. But by taking more and more samples, we can see, they're not behaving like it's better. They're behaving like a typical medicine that's only giving a mean average pain level of 50. So over the course of time, we could see that they're no better than the current status quo, and a type 1 error was made. We rejected the null when we shouldn't have. And the probability of a type 1 error is the p-value, because that's the likelihood that if the null was true, that's how often we'd get a result, at least that extreme. Now that was the only type 1 error that was made. There were a total of 20 different samples taken, and only one of those 20 samples did we make a type 1 error, which makes all the sense in the world because we're using a p-value of 0.05. Now here we can see company D, they're the winners. Their first sample didn't make it to the critical region. We didn't have enough evidence to convict, so we failed to reject the null. But in subsequent samples, all of those sample means were in the critical region, really small p-values. So in the end, after 5 of these samples, we could see, oh yeah, this is the medicine that's working, and the evidence suggests that. Now in this case, that first sample was a type 2 error because it wasn't extreme enough. We got a p-value of 0.13, so we weren't allowed to reject the null in favor of the alternative. So we had to stick with the null. But later we realized, oh, wait a minute, this medicine really is working. The true mean is less than 50, and so we made a type 2 error. We stuck with the null when we should have gone with the alternative. Now it's all based on us just following the rules and the standard of 0.05, but that's what it looks like to make a type 2 error. So, and then poor company A, they just kept getting mediocre results over here. So there was only one sample out of the 20 that behaved really strangely, and that was this first sample from company B. And that's why it was a type 1 error with a probably a type 1 error of 0.05. By using that standard, we expect 1 out of every 20 samples to be extreme enough that it fools us into accepting the alternative.